and welcome to the presentation of Team Radioactive for the drone, including our 5 team members for MECH 3334 Mechanical Design. So let's get started. On our first slide is a table of contents, just introducing what we will be going over today, the introduction and the drone and its 5 parts, as well as the conclusion. In the introduction, what we're pretty much trying to say is the fact that we needed a mechanical design, either we found, borrowed, or purchased, with at least 5 parts, so each member had a part to work on to know the forces acting on it, as well as any moments, and finding out the materials. Here are some pictures of the drone and what it looks like. We have a side view, and we also have a angled aerial view. So up first, we wanted to show a complete diagram of the free body because we wanted to show how some of those parts were working together. As stated before, we have an angled view of the drone and just forces and which ways we assume that they are working. And this is just a more detailed description of that free body diagram on the last page, which was the forces acting on each other as well as any moments. And then also the unknowns, any torque and power that creates speed changes, as well as not knowing if there's any wind resistance on day of testing or just a nice day out. So now we move on to the first part, which is the wing or propeller. As the function states, it creates thrust required to achieve flight. One of the main materials used in manufacturers is the ABS. And the young modulus and tensile strength shown is from the manufacturer, as stated below. Okay, and now we're going to look at the free body diagram of just the wing. And on the top picture, we can see the static forces of the weights of the wing acting down, and then the forces of the arm acting up. And on the second picture, we would like to imagine that it would be idling in the air. However, because it is idling, it's not moving, which would mean that the thrust force acting up would equal also the total weight of the drone acting down. Now going on to the second part, which is the arm, which is connected to the wing and also to the base. Later we'll see how it can also move into different sections just so we can get it to maneuver in different ways. And the materials for this one is actually the PLA. We use the manufacturer MakerBot 3D printers, and as shown, the Young's modulus of elasticity was provided after having completed the part. The free body diagram of the arm, we know that as well we have the wing acting down, and in the little circle at the bottom photo, we can see a little clamp that was made, and the top part will obviously be working down as a force to connect it to the base, and while the base will be working up to finish that connecting part. Any unknowns that were possible was the interconnection in that square, just because we didn't fully know in which direction those were moving or what else did or did not move, and just created either a force or a moment. Okay, and for our third part, the body, or otherwise known as the base, the function of this part creates connection to the arms, wings, and other features to create an efficient aerodynamic structure. The body keeps things in place to achieve balance and momentum. So it also uses the same material of the PLA, and was also manufactured with a MakerBot in 3D printing lab. So for the free body diagram, we can see summation of the forces, and what we don't see is what could be the drag resistance, as well as any effect again with air resistance or the gravity. And this is just a little bit more on that. Again, if it were to tilt over, how would it affect the body, which also affects the entire piece of the drone, considering it does connect the majority of the pieces together. So now we move on to our fourth part, which is the top. Again, it uses the PLA, and something I wanted to talk to you is about the PLA creates the drone to be environmentally friendly for users if it is no longer in use or reaches fracture. But by testing the material in modulus tests, it creates and prevents future fractures. And as you can see, we've used that material for 3 different parts because it is what the MakerBot uses. The function of this piece is just to keep balance and also keep from the electronics being exposed in case of any fracture or any complication. Now the free body diagram of the top, we want to say that it's pretty obvious. We have some tubes that connect it to the base, which are acting up onto the top, as well as forces from the screws acting down to keep it settled. Some unknown forces is just some aerodynamic changes that we wouldn't necessarily know until day of testing. And our fifth part, which is the connecting tubes. The main focus is just to keep or maintain the structural integrity of the drone. It can be used with plastic materials, but in our case we used aluminum tubing. And this is just different ways you can configure the drone to work. And finally, the free body diagram of those connecting tubes. We know that we have the forces acting up onto the wings, and we know that they also have a momentum which help the wings and propellers. What we can also identify with the unknowns is, again, any gear shifting in it, because we do need the electronics to get it up and moving. And this is just a price list based on different drones that are available and at what price you could pay for those drones. In conclusion, any problems that we encountered were mostly just the unknown forces and not knowing uh, what some of them were, as well as not knowing if we should weigh each part or just assume theoretically that either idling or stationary, they were just static forces against each other. Up until then, we just assumed that it was in an upright position and it doesn't flip, which would create even more forces in different areas. And that is pretty much it. It was a good experiment, and I hope you enjoyed.